Hello again. We're going to start our factoring problems. And basically factoring is a way of solving quadratic problems, or any type of problems actually, a little bit easier. Although I will have a lot of students that say they hate factoring and it's not easy at all. And I agree it's not, but it's not difficult because it's new. It's difficult because it works on a lot of division and multiplication aspects that students aren't necessarily as strong as they should be in, which is why they don't like it. That's pretty much the reason, actually. So when I say factor means that you have to pull out, or you have to pull out numbers in expressions or in equations. You have to simplify it. You have to put it in the form of a zero product property type of problem to try to make it a little bit easier. And you might not agree that it's going to be easier, but you're just going to have to buy along with it. And the first type of factoring that we're doing is factoring the GCF. And GCF stands for greatest common factor. So it's the greatest thing that they both have in common, or three things that have in common, or how many ever terms there are that you're trying to factor have in common. So my first problem is an expression. It reads 12x plus 42y. And we're not going to solve anything yet, but we're going to factor. Basically, what that means is we're going to take out what they both have in common. And I use a line from The Godfather 3, which I think is really good, but I'm going to wait and let you figure this out for a second. So I've got 12x, that's one of my terms, and 42y, that's one of my terms. What is the biggest multiple? I shouldn't say multiple. What's the biggest factor that goes into 12 and 42? Basically what I'm saying is, what number can you divide both 12 and 42 by? And then some people say, well, you can divide it by 2. And I agree, you can divide it by 2, but it's not the greatest number you can divide it by. Can you divide it by 3? I don't know. Can you divide by 3? The answer is yes, you can divide both of them by 3. But the biggest number you can divide them both by is 6. So, I used to not teach it this way, but then a student thought it was a lot easier if I did. And actually, I have to admit, it kind of is easier when you do this. What number can you divide both of these terms by? The biggest number you can divide both of these terms by. And it's not 12. 12 doesn't go into 42. 12 goes into 12, but it doesn't go into 42. You can divide them both by 6. Now, when you divide them both by 6, 12x divided by 6 is 2x. And then you got a plus sign. 42y divided by 6 is 7 with a y left over. Is there any number that goes into 2 and 7 that you can divide them both by? No. X and y are different, so you're fine. Done. At least my students think so. I'm like, no. This is where you use that line from The Godfather, part 3. Every time I try to leave, they pull me back in. You know, you factored it, you pulled it out, but you didn't actually divide it out. So what you have to account for is this 6. This 6 doesn't disappear. You write the 6 outside of this quantity. You create a quantity here, and then you put the 6 there. Now some students say, I don't get what you're saying. I'll show you. What's 6 times 2x? 12x. 6 times 7y is 42y. Basically what I did was I rewrote this problem, except I just tried pulling out, or dividing out a number, if that makes it easier. Dividing out something that the terms had in common. And that's factoring GCF. It's taking out what they both have in common. Now here's a question. What number goes into 24 and 4? Some of you might say, isn't it 4? Yeah, it is 4. But we're not done. This has 4 x's, well it's x to the 4th, x times x times x times x, and this has 3 x's, x times x times x. How many can you take out from each? Well, you can take out an x for sure from both of them. You can divide both terms by an x, but you can actually divide more than that. This has 3 of them, this has 4 of them. So how many can you divide at most? You can take out up to 3. You can take out the least amount. The lowest exponent in the variable is what you can take out. So if this were a 7 and this were a 5, you could take out 5 x's. This is a 4 and this is a 3, so you can take out 3 x's. It makes more sense though when I do the division. 24 divided by 4 is 6. X to the 4th divided by x to the 3rd is x to the 1st, or x. Plus, 4 divided by 4 is not 0, it's 1. And you got to be careful because sometimes students just cross it out and say, there's nothing there. No, it's still there. X cubed divided by x cubed is 1. I don't need 1 times 1. I'm done. Yes. No, I'm not done, because every time they try to leave, you pull them back in. What did I take out? 4x cubed. And if you don't believe me, 4x cubed times 6x is 24, x to the fourth. 4 times 1 is 4 with an x cubed left over. That's factoring out the GCF. But we don't work with just GCF with expressions. We use them in equations. And that takes a little bit more process. Basically, when you factor expressions, you're just trying to take out what they both have in common. Finito, I'm done, yeah! But when you're factoring GCF out of equations, not only do you factor, but then you have to figure out what the x value is. I mean, you got to figure out, okay, what x is going to be squared times 2 plus 8 times that x will equal 0. I don't know that, well, yeah, I do know that, but I know that because I was factoring it. But if you ask me off the top of my head, there's no way, I probably couldn't figure it out. Probably not. So what we're going to do is that we're going to solve this by factoring. We're going to take out the GCF. So what do the numbers 2 and 8 have in common? What can you take out of both terms? You can take out a 2. But we're not done. This has 2 x's, and this has 1 x. So well, what do they both have in common? They have at least 1 x in common. So you're dividing by 2x. 2x squared divided by 2x. 2 divided by 2 is 1. X squared divided by x to the first is x. Plus 8 divided by 2 is 4. X divided by x is 1. I don't need 4 times 1 unless there was nothing there. I'm done. Yeah. No. That's a quantity. Excuse me, my voice raised an octave there accidentally. And I've got to pull out what I divided. I can't just, every time I try to leave, they pull me back in. So it's 2x, quantity x plus 4, and it was equal to 0. Now if you were looking at the last lesson, which was zero product property, you should know what to do. 2x equals 0, and x plus 4 equals 0. Some of you might have already figured out the trick that my students so gallantly say, and they say, oh, I figured out a different way to do this, Mr. Shad, it's much easier. Good for you. I know it too, but I'm not going to teach it. I still won't show you how to do it. I would rather you figure it out on your own, and if you can't, then you solve for each equation. So 2x equals 0, divide by 2, 0 divided by 2 is 0. So, since I have no room, x equals 0, and I subtract 4 on each side, x equals negative 4. Those are my answers. Now, as I said, since I don't have much room, I'm going to erase these problems and put this one over here. But you have 6n squared equals 15n. And I don't think this necessarily should be said, but sometimes it's not implied. Whenever you have an equation, what you're basically trying to do is solve for an equation. When you have an expression that's something without an equal sign, you don't have to solve, you just have to simplify. But when you have an equation, you're always trying to solve. That's the end goal. Okay, this is good practice into the whole aspect of factoring because it incorporates multi-steps. The first thing you do when you're trying to solve an equation with factoring is get it in standard form. That basically means get everything on one side and get it set equal to 0. Let me say that again. Everything on one side, get it set equal to 0. Okay. This is not negative 11n. It's not negative 11n squared. It's 6n squared subtract 15n. That's because n squared and n are not like terms, so I can't add or subtract them. I can multiply or divide them, but I can't add or subtract them. And it's equal to 0. So the first thing you do is you get it in standard form. Everything on one side equal to 0. Put it from highest degree to lowest degree. So a square goes before the power of 1. Degree just means exponents. So highest exponent to lowest exponent. Now, next thing you do after you put it in standard form, put it from highest degree to lowest degree, is see if it has a GCF, a greatest common factor. Is there something that you can take out from both of them? Is there a number that goes into 6 and 15? And there is a number. And it's not 6, because 6 doesn't go into 15, but 3 goes into 6, and 3 goes into 15. But this has two ends and this has one end, so what can you take out from at least both of them? An n. So 6n squared divided by 3n. 6 divided by 3 is 2. It's not 3. Some people might put that. N squared divided by n to the first is n. Subtracted. 15 divided by 3 is 5. N divided by n is 1. I don't need 5 times 1. That's arbitrary, capricious, trivial. Okay, put it in a quantity. And my student says, oh, no, you're not done, because every time they try to leave, you equal to 0. Now you can solve this as a zero product property question. 3n equals 0, and 2n subtract 5 equals 0. Divide by 3 on both sides for the first one. 0 over 3 is 0. And add 5. Divide 2. N equals, you can't reduce 5 halves, so it's 5 halves. Now I have students that sometimes say, Mr. Shoddy, if I put 2.5, would you mark that wrong? No. I would never mark 5 halves to 2.5 wrong, given that you did all this work. If it was 1/3 and you gave me 0.333333 repeating, I might take a point off. It might not, it just depends how I feel at that particular time. If it's, if this problem were worth 2 points and you did that, then no, because you did most of the work, so it's fine. But if it were a 5-point problem and you messed up there, yeah, I might take off half a point, give you 4.5 points out of 5. But it depends on that, and you'd have to ask your teacher on that, and I'm sure your teacher would feel the same way. So leave it as a reduced fraction or as a decimal that terminates. But if it's a decimal that keeps going, kind of shady about saying change it to a decimal. Anyways, with that said, that's a brief introduction to factoring the GCF. Very important. It's the first type of factoring that we do. With that said, we're going to continue with more factoring and see how that goes. So have a good day for now. Goodbye.